For this video, we're going to go through both questions 6 and 7 because they're fairly short. So in terms of identifying what the behavior of these deformed mechanisms are, so this first one is our body translation. So you have the whole body not being deformed internally, you're just moving it over. This one is body rotation. Right, again, it's a solid block just being rotated about an axis. This one is our simple shear. Deforming it along the top and the bottom. This is going to be our pure shear. Right, somehow squishing it down and deforming it down this way and extending it out this way. This one is going to be our homogeneous strain. The body deforms similarly in all cases, whereas here we're going to have heterogeneous strain, where all parts of the body are behaving a little bit differently. All right, compare and contrast the following terms. When we're talking about stress, right, this is an external force placed upon a rock body. And basically strain is the internal deformation in response to stress. So that is that guy. And then if we go over to our failure envelope, this can be as simple as the envelope or the point at which the rock breaks. You can also go so far as to define what the different characteristics are, right? So we have our tensile portion, our more failure criterion, which is right here. Then we have our Coulomb failure criterion, our brittle plastic transition, and then finally our von Mises plastic yield transition. So you could have defined that, or just said it's the point at which the rock breaks. And then our diff stress, differential stress. Right, this is basically just unequal stress applied to a rock body. Our conjugate set, right, this is related to our more failure. Conjugate sets are sets that occur together. They're generally are 60 or 30 or 45 degrees. And this is due to what's called Andersonian mechanics. And then our coefficient of friction, which is mu, is the amount of friction internally a rock has before it breaks.